Yeah. So, okay. Ayush, just scroll up a bit. We'll go over this again for the people who are
Yeah.
looking at it on the recording. So, we shared two PDFs with you yesterday, and we'll just be giving a brief description about what was in those two PDFs. So, the first PDF is with regard to dual booting, and 18.04 is what we have built everything on. So, the our install.sh script and everything will work just on 18.04. If you're using 20.04, you'll have to figure things out on your own. You can reach out to one of us, we'll help you with links and stuff. 22.04, seriously not recommended because that uses ROS2, and ROS2 is very, very different. Uh, After that, for the Ubuntu thing, just so look, we have given a link over there. Download an ISO file for Ubuntu over there. So an ISO file is basically a file that will carry your operating system in a USB or any other storage device. So next you need to create a bootable pen drive. So some of you might have done this if you had messed up with your Windows installation anytime. But okay, for the bootable pen drive, the first thing you need to do is you need to format your pen drive. You need to completely clean it, and you need to make sure it is in the correct mode. So uh, you'll get all the details in the links that we'll give, and if something is unclear, you can just ask on the group or reach out to one of us. Then use this pen drive and install Rufus, which is a flashing software. And after that, it is basically a pretty it's a straightforward way. You need to create that sort of bootable USB, and then you need to turn off secure boot in your system. So that will vary actually give like what company your system is. So Lenovo's have different ways of turning off secure boot. Acer has a different way. So just you search your system
I
thing
like
on you.
just a
Yeah,
minute.
yeah. Go on, Ron.
Okay. Yeah. So just a minute. Oh.
Yeah, can we
Akshat, you
continue?
can continue.
Yeah, I'll just continue. So, yeah, you use Rufus, you made your pendrive bootable, you selected all the right modes. After that, turn off secure boot. Ayush, you could scroll down a bit.
Yeah, sure.
So in Lenovo and Acer, secure boot is turned off by default. For Dell and stuff, it's a little challenging to turn it off. So probably you'll figure it out on your own. If you don't, then just search YouTube for like remove secure boot HP, remove secure boot Dell, whatever. You'll get detailed instructions on how to do it. After that, next thing you need to do is you need to create space in your disk for Ubuntu. So just search for disk management tool, or I'm sure there's a .exe sort of run command for this, but just search it, and then you can create a partition. So right click the drive where you want to create this partition and create the partition, and for however much space you want. So ideally minimum space if you're just going to be with us for the summer school is 20 GB. If you are a project member and if you are interested in our later events, which we very highly recommend, then I suggest you go forward with 30 GB or close to 40 GB maybe. And other than that, like it'll help you like if you have a large drive, because later on it will be helpful for you the having a dual booted PC with decent space so that you can work over there. Okay, after that, I use just scroll down. So yeah, you can choose whatever drive you want. If you have just one drive in your PC, then just spread that. And obviously, this is completely reversible. Like if you want to finish your Ubuntu installation, just merge these two partitions together and you're good to go. Yeah, Ayush, scroll down a bit. So this is basically a description of how you create that space. You can read it up.
Also, when you're opening the shrink volume dialog box, like it will by default shrink all the volume that is there, like almost. So you have to like very carefully select how much space you want. So you must always like keep in mind, like if you want to allocate 40 GB, you have to select like the correct amount and then shrink it and then make the partition. Like just be careful while doing this step. That's all. Yeah.
Yeah. Okay. Scroll down. Yeah. So for Ubuntu, so now you reboot your PC and you get the boot up menu. So usually I think that is F9 or F11. What is it, Ayush?
I think yeah, F12. I think it is
Yeah,
for
F12. Yeah,
well,
F12.
and for
So
HP laptops and some of them have F2 also. You can search
yeah,
the
so
BIOS keys online. Like, yeah.
yeah, you can search for this. So there'll be a menu, and then you need to select boot from drive, boot from USB. There'll be something like that, and then you need to basically boot over there, and it'll guide you through a setup process. I use this scroll down, so it's a really nice UI and everything. You'll understand everything that's going on. Yeah, F2 in Acer, Escape, F2, F10. It's different. It depends on what kind of laptop you have.
Yes.
Yeah. So you need to go for install Ubuntu over here in this small menu.
Also,
And
we this is another method if you're not able to like locate the BIOS thing, but we strongly recommend you do it from BIOS because sometimes this can have certain issues which might occur. So, yeah.
yeah, basically, the more expensive your laptop is, the more issues will occur while trying to dual boot it.
Yeah. So,
So HP and Dell, which are like more expensive laptops, they make it a little difficult for you to dual boot. Acer and Lenovo are like completely chill with it. Yeah. So yeah, we can just go on.
yeah. So like once you reach this step, you will see install Ubuntu and you'll see try Ubuntu without installing. So if you just want to get a taste of how Ubuntu will look or how it will work on your system, you can do try Ubuntu. And in that, like it'll just be a temporary session, like a live session kind of thing. After you won't be able to save anything or do anything with the system because as soon as you boot off, it'll go off.
Yeah.
So you'll need to install Ubuntu.
So this is very much like if you know Python, then there's an interactive mode. So it is like that actually,
Yes.
except the drive access. Yeah.
It's basically like I mean if some of you have been into gaming before, like basically if you don't save a game, you have to start from scratch again, right? Like in, uh, similar to that basically. Yeah, continue.
Yeah, we'll just so right, you click install Ubuntu, a wizard appears, and yeah, there's this good installation process. It makes sense if you just read everything, it'll make sense.
Okay, this step is a bit important. When they ask, do you want to install latest updates from Ubuntu server? Only if you trust your internet connection, by which I mean, please do not do it on IITM LAN. So only then you should select this option. Else, you can always do it later on. So I'd recommend you skip. I mean, do this option only if you're connected to Wi-Fi or you have some stable internet connection. Because if the connection say tapers in between, then it can cause serious trouble. Like if the installation suddenly stops in between. So yeah, yeah, Akshat, you can continue.
Yeah. So okay. So basically, these are pretty straightforward steps, but we'll just read them out. So the next screen will come. How do you want to install Ubuntu? Select something else and follow the instructions over here. So actually, there's a very good YouTube video that guides you through this. We'll send the link to that as well. Then this is important. Select exactly the partition that you had made. If you select a wrong partition, you will get it'll be bad. It's not good. So select the partition that you had made for Ubuntu that was empty. And yeah, okay, select the mount point as slash and it will become your so this is similar to the home directory thing that we had. So this will become your primary partition.
Yes.
Yeah. Okay,
This
then you
here is
can.
the mount point thing, like where you have to put this thing. This basically means the primary partition which is being used is at root, which is in the home directory. So
Yeah, then you press continue and the it'll take 5 minutes. It'll ask you your location for the time settings and everything. And 5 minutes is all it takes basically. Yeah, location select India. Don't like usually it has some city when you look for the
Kolkata, it
India
has,
time
it
zone.
has
Yeah,
Kolkata
usually it has Kolkata.
as
So
default.
just
Just
select
select,
India over here.
yeah. After that,
Right.
it's, yeah.
Yeah, just keyboard layout and stuff. And finally your computer name, username, password, everything you can enter. Okay, make your username really, really small. Like the first letter of your computer name, the first word of your computer name, make it small because that becomes your username. And later on, like if something goes wrong or when you are configuring your graphic cards, if you want to do that, then you will have to remember your username. Yeah.
Yeah, yeah, for
Okay.
later on. Yeah. Yeah, after that, it's a straightforward process. Um,
Yeah. Okay, the VM installation is actually much easier. If you have VMware, then it'll actually guide you through it and make you choose an ISO file and everything. Just don't change the location of that ISO file as you keep doing stuff. Like if it is in downloads, let it stay in downloads.
Also, once you dual boot Ubuntu with Windows, when you restart the system, instead of going directly to an operating system, it will first show something called like Grub. Grub is basically, you can say, like an operating system manager. So it will provide you options for which operating system to choose. So if you want to go to Ubuntu, like Ubuntu option will be there. If you want to go to Windows, there will be something called Windows Boot Manager. So you have to go there and then
Yeah, then your normal Windows
yeah.
will come up.
The thing is, I actually wanted to show a demonstration, but since I won't be able to show it while the grub is on because Teams won't work, no, like when grub is on. So, but I'll send a screenshot of that by today.
Yeah,
So you
it's very
guys,
similar to the thing you saw above, which said install Ubuntu for a small time, install Ubuntu proper, that menu.
mhm.
Try Ubuntu, whatever it was. Yeah.
Yeah.
So here we've given you some links for the VMware workstation. Yeah, I think we are done with this document. Now we'll go to the next document, the installation. Right. So the installation, we have actually made it very simple for you. So credits to Pranit. He has made a very good installation script that will work on 18.04 systems and install basically everything we need. Now, for that, we have uploaded the script on this link and we tested it on a brand new system with a fresh Ubuntu 18.4 installation. So it didn't give us any errors. It might give some errors in case of. I remember once I had an error in IITM when I was using the LAN, but without the LAN, when I switched to my mobile hotspot, it didn't give me any errors. So after that, you go into your downloads or wherever your downloaded files are stored, and ls you'll be able to see it. So yesterday we told you that before running something like this you need to do the chmod plus x thing, so make it executable. And after that dot slash, so this sh file, what do you call it, file extension, that is basically a shell script. So it is, shell script is a fancy way of saying that something that runs on your terminal. So basically, imagine that you took all the terminal commands, had them in one file, and they'll run by one by one. So that is basically what a shell script is. So if you're interested, you can actually open this shell script and see the commands, and maybe even toy with the commands, and some of them are just for beautification. And yeah, after that, just run dot slash install dot sh. It will take a solid 2 hours on a fine internet connection. 1 hour if you have a really good PC. And yeah, scroll down, Ayush. Yeah, it starts working and keeps going. We have put yes no prompts in there. You can open the bash script and see how we have done that. And in the yes no prompts, keep clicking Y for every single installation. So 2 to 3 hours depending on your internet and processing power. And yeah, 1 hour 40 minutes for Pranit system. Okay, so just as a small extra, Ayush, could you open the install.sh script? The link is right there.
Yeah.
Let's see if we can download it quickly, we'll open it. Else we could just host this on GitHub or something.
Mm-hmm. Right now it's on. It's is it a drive link or something?
Yeah, I think it's arrived then.
Okay, it isn't opening. 1 second.
Yeah, it's arrived then.
Uh, no, if I can get the link directly, wait. Okay, for some
Okay,
reason.
Pranit, are you in the call?
Yes, yes.
Yeah, maybe you could show the shell script.
Yeah, yeah, sure. Just a minute.
I'll stop here.
Is it visible?
Yeah.
Right. Yeah, so yeah, this is the shell script that we have made. So basically, it will ask you to install ROS first, and that this is just the installation part. Then it'll ask you to install Ardupilot, and then this is the Ardupilot installation. And then lastly, it'll ask you to install Mavros, and it'll install Mavros also. And then it'll like show the basic commands that we'll be using to launch all the files here. So yeah, that is how the shell script basically works.
So yeah, you can see like some insights over there. So like normal if else conditions that we can put. And right, if you want to be really creative, then as a small bonus assignment, you can create a small shell script to do like basic things. Make a directory, upload it, download something on it, whatever. Right. So yeah, you can see that read command. So that basically shows you that thing on uh it's basically like an input statement in Python that you enter a string and it will show that string on the terminal and then you can enter a value for that string. And yeah, this is basically how an sh script works. So actually later on you can write this is actually something very fancy called Linux client and bash scripting. So you can write this somewhere if you do it. Yeah. Pranit, you want to carry on?
Yeah. Can you like start with the ROS things? Give me 5 minutes. I'll just like get the
Yeah,
PDF.
yeah, sure, sure.
Yeah.
So the thing about ROS, okay, we started with a basic ROS introduction yesterday. So now we'll sort of build on that. So a ROS is basically a software that holds together different programs. So usually the crux of this software is ROS core. Is a command called ROS core. So what ROS core basically does is that it sort of threads different commands into it. So the reason that this works better than most normal simulators or anything rather is that it will allow you to run so many things at a time, like an unlimited number of things at a time. So right, so yeah, this is the raw score command, and you can see like the basic things that are happening. It starts with a PID, so that's a small controller, and yeah, so of course, if you use a ROS launch command, which we will come to earlier, you don't have to do a ROS score. So other than that, anything else you're doing in ROS, you'll have to do a ROS score. And uh, the other thing, Ayush, maybe you could carry on with some ROS basic.
Yeah, sure.
Yeah,
Uh,
because you can present.
yeah. So if you look a little bit carefully into this command, it says something logging into home ayush.ros log. 4134 something, and then something. So basically, when you install ROS, there is a log file which keeps a track of whenever the system started, how many times you used ROS core, what all happened. So if you want to see this file, I think you will be able to see this if it's not hidden. What was? No. Yes, as you can see, I have used ROS core many times. So you can see the log files basically. Like the reason for having these log files is basically to see how many times like ROS core successfully ran and like how many times we were able to use it properly. Um, the next thing is that it will see if you have enough space, like enough RAM, so as to say, to run ROS core. So you can see
Uh,
I'm checking log.
Ayush,
Yeah, yeah,
yeah, I got the PDF. I'll share.
yeah, sure, okay.
So actually, there'll be a point when you're using ROS when that thing will give you an error that the disk space is more than 1 GB and it will give you a small command to clean the logs. So yeah, that's an interesting thing.
Yeah, is it visible?
Yeah,
Yeah,
yeah.
it is.
Yeah. Carry
So yeah, as we went on, ROS is robot operating system and it's a flexible framework for writing robot software. So one small interesting factoid, you don't have to use ROS for anything related to robots. Like if later on you want to create any sort of two programs that interact with each other, let's say one keeps giving out an information and the other keeps accepting it, you can use it, you can make it through ROS. It does not need to have anything to do with robots because manually threading a lot of programs is actually more difficult than using ROS. Yeah, so Gazebo, we showed you some Gazebo yesterday. So it's a 3D simulator and it runs on a Mojoku physics engine. So it was designed to evaluate algorithms for robots. And if we combine ROS and Gazebo, we get a very powerful robot simulator because ROS will run all those individual things together and Gazebo will test it out against real physics. So, yeah, so you can generate basically worlds in Gazebo, which are indoor environments or outdoor environments or whatever kind of environment you want to make. So as I showed you yesterday, you can control things like wind, magnetic field, gravity, everything. And right, so I maybe Pranit, you could go on.
Yeah, okay. So the question is like, why do we use ROS and why not any other thing? So uh, the most appropriate answer for this is like ROS is first of all compatible with many things that are available, and the second most important point which I find is there is only one programming language that is required to run ROS, and also like it can be used to simulate using hardware. These are all the bonus perks that you get. So we'll give a small read through it. So like robotic thing, the Akshat, I think he went over it, and there is only one programming language you can use like all over ROS, whichever you are comfortable with. In most of the cases, it is C++ and Python. I mean C++ or Python. But like of course you can like combine. You can use both the languages as well as according to you. And the another major benefit is you don't need to develop your own code for many aspects of the robot. There are so many pre-built libraries and functions, and like even today we'll go through topics and the nodes, so you'll get to know about this in detail. uh, okay, so what if we did not have ROS? So first thing, as we know that like ROS is used in simulating stuff. So if we don't have ROS, okay, so we cannot, like let's say we'll now simulate the movement of a drone in a world or something. But what if we did not have ROS? So we would not be able to simulate everything, every single thing in proper physics. So that is why ROS is very important if we do not have hardware. Like let's say this summer school is online. So if we did not have ROS, we wouldn't be able to like show you all this stuff. Next thing is there's like no need of complicated protocols in ROS. But if you don't have ROS, as like I mentioned here, you need to develop your own code for all the aspects of robot controls. So that is one more thing which is which is very, I would say, convenient with ROS. And as I mentioned here, ROS is only a single framework which works with almost everything. but other things, other which is available in market, they don't have like very diverse. They have very diverse frameworks, which is a bit difficult to implement.
Also, one more thing, ROS is completely open source and has a very good community online for like for support. Like if you're say stuck with a task, like certain task you have to do on ROS, it's almost like a 90% chance you'll find someone with the same problem online which has been solved. So that way
Yeah,
it's
there is
also
a lot of documentation for us.
yeah.
That is a huge advantage, which we forgot to mention here. Yeah. Okay, moving on to Ardu Pilot. So what Ardu Pilot basically is, if we talk in simple terms, it is just an autopilot. Well, like you might know, all the planes use a sort of autopilot to control. So Ardu Pilot is also one kind of, you can say, autopilot, and it can be used not only in like airplanes, but it can be used in drones, it can be used in ground rovers, it can be used in submarines, and all that stuff. Also, this is it. There is a technical term for this, which is called software in the loop. Which we'll like go through later. It is called SITL, and some features of Ardu Pilot are, yeah. So, okay, one thing regarding Ardu Pilot is it can allow you to like complete it can allow us complete autonomous flight. Like you don't need an RC control for it. You just plan your path in Autopilot interface, and the object or the UAV will fly according to whatever path you are planning to it. So that is one huge advantage of Autopilot, and it is also very stable. There are like very less errors if you implement it properly, which I would say is a tough thing to do. But yeah, if you learn it properly, then I would say it is a very good tool. And also it has a lot of sensor integrations, so you can easily integrate cameras like FPV cameras on drones, or maybe lidar sensors, and you can also like stream live video uh, through a inbuilt software, through an inbuilt framework in Arduino Pilot. Also it is very popular. It is being used by Boeing as well, and it is like completely maintained by hobbyists on the internet. There is like not a very official organization for Arduino Pilot. Also, if you guys heard of Google Summer of Code, so one of the projects that they have is Arduino Pilot project. So if you guys are interested in exploring more next year, maybe you can apply for that.
Yeah, also building on that, in Google Summer of Code, basically any open source project you can contribute to. So you can even contribute to ROS actually. So yeah, if you're interested, then next summer you guys could try that.
Yeah. Akshat, would you like to take, or I'll just have some water and come?
Yeah. So okay, this is the uh yeah, this is the basic disambiguation of ROS, what it contains. So the most basic part of ROS is a node. That is what like the building block of ROS is. So a node is basically an executable that uses ROS to communicate with other nodes. So as I said, they are basically programs that are communicating with each other using ROS. Right? So for example, you have one program for a camera, you have one program for a robotic arm, you have one program for a leg. So all of those are basically communicating with each other and working together. So the basic ways that or nodes communicate with each other is through messages. And messages are contained within topics, and you subscribe and publish to topics. So this is okay, very complicated to go across. So I'll break it down again. So the biggest thing is a node inside ROS. A node is basically something that you'd have a robot ka node. You'd have uh, like a robot would have one node normally, and within that you'll have different topics. So you'll have a topic for the amount of current you're giving to its arm. You would have a topic for the amount of current the let's say there's a sensor on it, so you'd have a topic for the sensor. You would have a topic for the what let's say the robot has something that listens like an ear. You would have a topic for that. So that is what a topic is, and that topic will have messages inside it. So let's say one message can be the current, one message can be the voltage, one message can be the orientation of that arm, like in terms of theta and xyz and everything. So all of these are like different messages, and messages are basically like data types. So if you look at a message, it will basically look like a class. So if you know programming, then object-oriented programming, then basically a message is just a class. And after that, Pranit, you could continue with master and draws out and draw score.
Yeah, just a sec. Yeah. Okay, so master is one of the service of ROS. So like whenever you run ROS core, yeah. So you could see that there is a master topic. There is a master service running here, and when you end, like when you cut, so master is killed on exit. So I don't want to go it in much of a detail because it will be very confusing at early stages. But yeah, you can like tell that it is like a service, and every time ROS is running, this master service always runs. And the use of it is to help find nodes, and we'll cover this when we learn nodes. And ROS out and ROS core. ROS core is like master plus ROS out plus parameter server. And ROS out, I'll just tell you while we build workspaces. So, okay, one thing, I feel that we are going a bit fast. So, like, would any of you want to like ask us to repeat anything, or maybe like we should go slow or something? You can just tell in the chat. Who else? Okay, yeah. So you allot the space in MBs, but the space you're seeing is in GBs. So 1 GB is like 1024 MB. So I think that is the reason why this is happening.
Yeah, there's
And
that 24 multiplier.
yeah,
10.
yeah. So if you guys want us to go like a bit slow, or maybe like explain something again, because like these are the basics, and if you miss on this, maybe like it'll be a bit tough for you to continue. Like you will understand obviously, but it'll be easier if you like go through this again. So if you want us to repeat any part again, so you can just like ask us right now, we'll happily do it. Otherwise, hey, 5 GB is okay only. No, I mean it won't make much of a difference, right? There's, I think there is this 24 multiplier thing only, I'm not sure. Yeah, so like any of you would like us to repeat any topic, anyone, just feel free to speak up. We don't want this to be a professor lecture where no one is speaking to the prof and the prof just feels sad. So yeah. Okay, so like shall we carry on? Okay, yeah, we'll be giving a break at, let's say, what is the time? It's 5:48. We'll be giving a break at 6 o'clock. So 10 minutes you can go and freshen up, or maybe have some snacks or something, and we'll be back at 6:10. So okay, so let me continue then. So when you're done with all the installation, so your home should look something like this. So you'll have an Pilot folder, you'll have an Pilot gazebo folder, and rest of the things will be hidden here. So for hidden things, you can just press Ctrl H, but that's not required right now. So I'll just switch it off. Okay, and one more thing, there is a file called .bashrc here. So Ayush, would you like to explain about this?
So basically, .bash rc file contains all the commands which will start as soon as you start up the system. So, like the GUI you see, which appears immediately after your computer starts on, like via Firefox, File Manager, the terminal, or all these text editor, and your basic applications, your basic like battery system, all those things, basically everything which you see immediately on startup is included in the bash rc folder. So now, whenever you open a new terminal, if you want to use ROS, and you have not, and if you want to use ROS, you have to source basically the ROS files. Um, so instead of typing this command again and again, yeah, this is the command source opt ROS melodic setup dot bash. Instead of typing this command repeatedly in every terminal, we can just include it in our .bash rc file. So whenever a new terminal is opened, .bash rc will take care of this command. So as you can see, for various other reasons, like we have put a lot of commands. Like you'll get to know them later on when we introduce gazebo and all. But yes, basically, if you want the same command to be run in every new terminal you want, you can include it in the dot bash rc folder, and it will uh, start up. And how you do it is you go to the terminal, you type get it or whatever other text editor you use. Could you show that Pranit, that?
Okay, yeah.
Dot bash rc, and this will open up. Probably you could close this and then like
Yeah.
relaunch the command. Close it here. Close it, say. Yes, so you'll see this thing coming up, and then supposing you want to add that command, source opt ROS melodic center, just add it, save it, and then the next time, yeah, and then the next time
Oops.
you careful, bro.
Yeah, yeah. Yeah, so you can just save any line you want, which you want to execute as soon as you start a new terminal. We'll get to it later on when we make workspaces, and also you'll have a clear understanding to it. Also, for those who don't know, gedit is just like a notepad in Ubuntu. So
Also, one more thing, like I'm sure, like if maybe some of you might have experienced this when you install Discord or MS Teams, it'll start up on it'll start up as soon as you start with the computer, unless you turn it off manually, right? That is because even in Windows, okay, Windows is a different case in this case, but if you have Ubuntu and you're installing Discord and MS Teams and it opens on startup, basically that command would have also been automatically updated on the bash rc to open that MS Teams. So either you can go to the application and turn that off, like don't start on startup, or you can even go to the bash rc and delete that line. So it's effectively the same thing. Even Spotify, for instance, I think it happens with Spotify also, no? Right, like when you install.
yeah, yeah.
Yeah, yeah, continue.
Okay, yeah. So like by this time, anyone has anything to ask? I'll wait for 1 minute if anyone has anything to clarify regarding whatever was taught today or yesterday or any installation procedure as well.
And if you're going fast, please tell us. Like we'll
Yeah, yeah,
just.
please tell us because like see we all are like known to all this stuff. It is you who's new, so we want you to learn it properly so that you don't have any errors. So that is why like ask us to go slow if you want.
And ask any doubt you feel. Just don't think that some doubt is too like
Dumb to ask. It's
too
nothing
dumb.
like that. We had even uh, I don't want to call that, but okay.
Yeah, yeah.
Okay, then I think I should continue. Okay, so now moving on to what is called Catkin workspaces. So let's say you are doing a project right now. So like assume this summer school, whatever you're learning, take it as a project. So you'll be creating a workspace in which you'll be storing like all the packages which you'll be making, and all the work you'll be doing, you'll be storing in this workspace. So this is called Catkin workspace because like Catkin is a pre-built tool which is used to make workspaces. So that's why this name. Okay. So how to create a workspace now? So we could create a workspace in the home tab itself, home directory itself. Wait, why is this opening? Yeah. So as you can see, there is no workspace over here. So I just make one. So what you do is mkdir as we discussed yesterday. So mkdir is make a directory, and we'll just type help so we can learn as well. So there are 4 arguments to this and 3 text arguments to this. So mode is like set file mode. So when you make a directory, if you want to give it administrator permissions or let's say executable permissions, you can just use this command, but I don't think it's needed right now. /p is like parent directory. So if you want to make a directory inside the directory, so instead of using it twice, you can just use -p, which we will be doing now. -v, and I don't think that is needed. You can just read through this if you want. You can take a screenshot right now, or you can use it in your system as well. And yeah, so I think, and as I said, double dash help, so that will display. This works with all commands in Ubuntu. So okay, so I'll just make a workspace. So we'll name this as Catkin workspace, and inside I'll make a folder called src. So src will be the folder which will be containing all the packages and everything which we'll be making. So yep. So now if you go here, you'll see a folder called catkin ws, and if I open it, there will be a folder called src. Right. So now to make this is not a workspace right now because this is just normal folder. This doesn't have anything. So to make this into a Catkin workspace, I think I have forgot to mention it in the PDF. Yes, yes, I'll add it. Don't worry. But yeah, what you do is you do a Catkin init. So what this does is this converts the folder into a Catkin workspace. So as I press enter here, yeah. So now, see, there are four things required for a Catkin workspace to exist. One is the build, devel, source, and log. So we only need the source space right now. And oh wait, sorry, just a sec. Okay, one thing I forgot to do is I needed to cd into the Catkin workspace. So yeah, don't make this mistake. Okay, so we'll cd into the folder that we just made. So now we are inside the folder, and as you can see, we have a folder called src over here. Okay, so now we'll look a catkin in it, and yeah, so the source space exists, which is nothing but the src folder. You can see the path over here, and since all these were not present, so it will automatically create them. So you just need a source space for making a workspace. So now if we open the folder here, so you can see, just a second. Yeah, so now, so these are missing. Now once again, if I do catkin build, so catkin, what catkin build will do is it will start building the workspace. So there is a thing called catkin tools pre-build. So it will start like making the workspace configuration. And by now, I think, yeah, see, you can see build, devel, logs, and source. So all these four folders are present. And this devel will also have some files which we'll like get to later. So basically, this is how you create a workspace. So yeah, so anyone has anything to ask in this? Just to recap, I'll tell you what we did. Yes, so we first created a folder, and we first created a folder called catkinws and a folder called src inside it. Then we cd'd into the folder. So we went inside the folder, and there you have already made an src folder there. Then you press catkin init, so it will initialize the workspace. What catkin init does is it will create this folder called catkin tools. So if there is a .catkin underscore tools folder present, that means this folder is the catkin workspace. And this is all these readme and stuff. You can go through it if you're very much interested. Personally, I don't want to. And then you do a catkin build. So since there are not any packages in src right now, so there was just one thing that was meant to be built, which was the tools pre-built thing. And yeah, so it built this thing starting and finished, and it took 5.7 seconds, and all one package succeeded. And once you build a package, it doesn't need it building again unless you change something in it. So yeah, this is how you build a package. Ayush, Akshat, do you have anything to add to this?
So just one thing I wanted to ask you guys, like before this, Pranit hadn't like gone into the Catkin workspace folder, right? And like after that only he did the Catkin build. Now my question is, what would have happened if he had done Catkin build in the home
Oh,
directory? Can someone like guess or something?
By the way, like don't take partial information. Don't test this out right now.
Yeah, yeah,
yeah,
yeah.
please,
Whatever
please.
you do.
Yeah, so I'll just repeat my question. Basically, he created a like a directory called catkin ws. Then he went inside the directory and then he initialized catkin and then he did catkin build there. If he had not gone into the directory and done catkin init and catkin build, like without going into that catkin workspace, what would have happened? Like any, you can answer anything. Like would the command have worked? Would it throw some error, or
Yeah, it
would it
does not.
run normally?
It does not need to be correct. You can just like
Yeah, yeah.
guess.
Yeah, just make a guess.
Because like see from personal experience, guessing is how you learn things. You guess things, then someone will correct you, and then that is how you learn things. So yeah, you can just give it a shot. It does not have to be correct.
The whole home directory becomes workspace.
Yep.
Yes.
So anything you'll do, it will have like the home directory will be a workspace, and all the other things which are present in the home directory won't work properly because it is not meant to work in a catkin ws.
Yeah. And also in some documentations and everything, you'll find catkin underscore make instead of catkin build. So that is basically an older version of catkin build. And it works just as well, but you won't have like a colorful terminal and everything. You
Yeah,
just
this
enter
is
catkin make. It'll tell you that you're not supposed to use this command. Like
yep.
you can either use catkin build or catkin make.
Once you use catkin make in a directory, after that you can only build the packages using catkin make. Same goes for catkin build. You can't use both the commands simultaneously
In the same workspace.
in the
Yeah.
same workspace.
And also, like, I think I should mention this as well. If you, like, by mistake, catkin build or catkin init or non-intended folder. So let's say I just did it in my home. So, like, it won't work properly now. So what you need to do is you need to find a folder called .catkin underscore tools. If you delete this folder permanently, then your home, like, it will be restored as it is. You won't face problem. So by mistake, if you do this somewhere you should not, so you can just delete the .catkin underscore tools folder. So it will return back to normal. So yeah. Okay. I think yeah, we can go on a 10 minutes break right now. You guys can like go and freshen up or something. We'll continue at 6:10. Can you please mute whoever is playing songs? All right. So I think
Yeah,
we
we
can.
can continue.
Yeah. Okay. So yeah. So anyone has like anything to ask, maybe, or else I think we can go on.
You can go on this.
Yeah. Right. One sec.
Yeah.
So when we okay, so look, what bash RC basically is, it is a hidden script. So if okay, so if anything starts with a dot, then that is meant to be hidden. So whenever you open a terminal, okay, so like the default in Ubuntu is a bash terminal. So whenever you open a bash terminal, so whatever is there in the bash RC, so it will execute that and then only open the terminal to us. So let's say we'll talk about sourcing and all right now.
Yeah.
So let's say you want to source something. So ideally you do it manually. Yeah, I'm not sharing the screen right now. If you do it manually, so you should like type it in the terminal every time. But if you
I
just add
think
it
I
to
think
the
we could just show this, Pranit.
okay, fine. Just a second, I'll start sharing. Is it visible?
Yeah, it is.
Yeah. Okay. So okay, I'll open the terminal and okay. So like we made a workspace called Catkin workspace, and if we go into the devel folder, we'll get to what all these folders are, and you will do an ls, so you'll find all these things: local setup .bash .zsh .sh, whatever. So this is the file that we are looking for, and you need to source this file whenever you are working with a workspace. So if you want to do anything in the workspace or with the workspace or related to the workspace, you should have this file sourced. Okay. You can look up the definition for sourcing online. I don't think I can explain it here in a good way. Like, so you can just look it up. It's not a very big deal.
Yeah,
So you can,
basically what will happen is if you
yeah,
try to do this without sourcing, it will not be able to find the executables inside that folder unless you source it. So your executables inside SRC, your packages won't be detected unless you source.
yep. So what you ideally do is you type source and then you type the selected file, and then it gets sourced. It will not show any output, but this is what you should do. But you won't be doing this every time when you work with a workspace, because in future you might have multiple workspaces, or maybe like you forget it sometimes. So what you should do is you can go in home, you can open uh, the bash rc.
So gedit is basically, yeah, you'll just see, yeah, this editing thing.
Yeah, so you can
It's
just
kind of
type.
like a notepad.
Yeah, so the path of that was catkin workspace, and then it was in the devel folder, and the name
Setup.
of the file is setup.bash, and you can just save it. Yeah, so it got saved. Now you don't need to do this every time you like work with the workspace. This will automatically have it whenever you run the new terminal. So you can just like have a new terminal open, or maybe if you want to like work in the same terminal, so you can just do a single dot and then bash rc. Oh, sorry. You can just like okay, you can just source it. No need of dot and all. You can just source it. So if you source bash rc again, so it will like refresh, it will run all the files in the bash rc again, and you can just work in the same terminal. Or what I recommend is you close this, you run a new terminal, and you work here. Okay. So
So
this was
basically,
about,
the bigger your bash RC is, the slower your terminal is. That is
yeah.
also
If you like
something.
add a ton of commands in the bash rc, it will take a lot of time
So I
to
guess you
open.
all can like appreciate how important like that bash RC file is. Like if you want to imagine if you would have to do source level setup.bash for each workspace you're using every time. It'd be pain.
Yep. So I'll give you an example. So last year we had a project of the wind turbine drone. I think many of you might have heard about it. If not, then it's fine. but we were working with 4 separate workspaces, and you can obviously not source each and every workspace after you open a new terminal. So you can just add all the files in the bash rc and it'll do the thing automatically. Okay, so moving on. Okay, anyone has anything to ask, you can just unmute or type in the chat. uh, Yep, so we are done with making the workspace. These commands we'll get to later when we make packages, so so they'll be easier to explain. Moving on to packages, Akshat or Ayush, maybe you want to.
Yeah, so a package, let's say very visually, what is a package? A package is a folder inside your SRC. In all its, in all simplicity, that is all it is. So officially, it is a collection of which contains libraries, your executable scripts, and your SDF and URDF files.
Yeah, all the
So
words or the models that you'll be using in Gazebo, it can contain that too.
yeah, so this time we'll be okay. Anyway, so right, if the simple way of creating a package is just make a folder inside your SRC and do a catkin build over it. So that will actually create a package for you. That is all you need to do. Other than that, one thing you need to keep in mind: if you delete a package and you do a catkin build, it won't work. So you'll have to delete your catkin tools. You'll have to catkin build again from scratch, and that is how you can do that. So inside your package, you'll have basically usually it has a description of whatever it is you're launching. It has launch files. It has world files. The world files is the surrounding with which it is being launched. Launch file. I'm talking about a gazebo simulation right now. Launch file contains uh, the dot launch files for the model, and there are description files, that is URDF and SDF. So these are basically fancy terms for description. So description will basically tell you the physics, the geometry, everything of whatever it is you're running. And finally, it will have scripts, which is the executable Python or C++ scripts that you will run in that environment. So yeah, that is basically all a package is. And you can obviously create the package using cat can create package. Honestly, I prefer doing it with creating a new folder mkdir. That's all it takes. But yeah,
Yes.
this is the official way of doing it.
So like you can see a depend one, depend two, depend three written in front of it. These are basically what all libraries or what all dependencies you want to keep with the package. So for example, if you want to use ROS by ROS CPP both, like while writing the code for a ROS, like for like a control script or something, then you can just mention ROS by ROS CPP. And we want to use standard messages. We'll come to that later. What STD messages is? There are many types of messages like STD messages, general messages, etc. You can add that, and then just when you run this command, it will create. So, Pranit, could you
Also,
understand?
yeah,
Go ahead.
one thing, if you are wondering what ROSP and ROS CPP is, so you I think you all would have gone through that course of CS 1100. So whenever you start writing a program, you include IOStream. Okay, no, sorry, it was stdio.h, right? So
Hmm.
you include stdio.h in the header.
See.
Yes. So in C, yeah. So and in Python, those who use Python, you type import whatever you want.
Crossfire
Math import,
and
yeah.
yeah.
So
NumPy.
ROSPy and ROS CPP are like pre-made libraries which contain all the functions that ROS uses. So we'll show how to include this later. So in Python, we just include ROSPy. In C or C++. Okay, there is no C in ROS. We just use C++ because it is better. And yeah, so you can just include ROS dash ROS cpp.h. We'll teach you that, not a big deal. So we'll now create a package named beginner tutorials in our Catkin workspace. So let's just cd into Catkin workspace and src, and now we'll create a package. So as you can see, there are certain things which a package generally has, which is an XML file. It has a CMake list file, and then every package has its own SRC file as well. So I'll show you. If this is a bit complicated for you guys, I'll just show it here. So this is the package that we made, and these are the things that it includes. So include it's not relevant. All the things which we'll be doing, you can create a new folder here, or you can store in src also. And okay, so now whenever you make a package, you need to do a catkin build in your workspace because you're adding something new to your workspace. So ideally catkin build should work everywhere in the workspace, but to be safe I'll just go back to like my catkin workspace folder and I'll do a catkin build here. So as you can see, it has succeeded. So started and finished. So this is how you know if your package building is successful or not. And so yeah, this is how you make a package. And now in your package, let's say we'll be working with nodes and all. And so now I think we should like keep the infrastructure aside and we should move on how ROS actually works. So
Okay, just
yeah,
one thing I wanted to add.
yeah,
Like for instance, if you're making a package and you're not sure of what dependencies you will use, like probably you'll find that out later. So what you can do, you can just do catkin create package and then package name, and then leave out any dependencies. Then you could go to the Pranit, could you open that folder, that beginner tutorial? Yeah, you can go to. Could you open that cmake lists.txt? Okay. I just like zoom it a bit. Yeah, so now you can see like since we typed, could you scroll up? Yeah, since we typed ROS CPP, ROS by standard messages, you saw that find package cat can require components. This becomes like, um, I mean, this automatically came in that cmake If we had not typed this ROS CPP, ROS by standard messages, then it would have been commented. Like you can see these two hash symbols, right? So in case you created a package and then you later realized, okay, I need ROSPy in this, I need standard messages in this, and I need something else in this. What I can do, I can just uncomment that particular line, find package, cat can record components, add these things, and then I think, could you scroll down, Pranit? Yeah, that's it. Then just like save the cmake and then just continue with the.
yeah, I think this is like way too much complicated.
Yeah,
So
yeah. I'm just yeah. For those of you who are interested, can like
okay.
this way.
So I think like this was a bit very much technical to understand. So I'll just go over it once more.
So why?
So
Okay,
what?
there's an important question. Why is a workspace important? What happens if I don't create a workspace? So I'd like to answer that. So if you don't create a workspace, you cannot create a package. That is basically all it is. You create a workspace to create and manage your packages. So a package is something that you will run ultimately using ROS launch and ROS run. So you can't do anything without creating a workspace first. All you can do is work with pre-built and hidden ROS packages. So things that you basically use your apt-get to install, you can run those, but you can't create anything, you can't edit anything. Yeah.
Yeah. Okay. Like I think this was a bit. We went over this a bit fast, so I'll just repeat what I said. So we are trying to build up. We are trying to create a package, and what package is that? It will contain all the libraries or all the scripts that we'll be using to. Okay. So let's say we are working on a project to make a drone move in a certain path. So for that, the all the movements of a drone will be compiled into a workspace, and inside the workspace, let's say you need a package called a movement of a drone, and inside that package you'll be storing, let's say you make a path for a square and a circle, so inside the package you'll be storing square.py and circle.py, square.cpp, circle.cpp. So that is how it works. If is there a paint kind of thing in Ubuntu? Okay, I'll just get
But you
that.
can just use Jamboard.
Jambo. Yeah.
Okay, fine. Jamboard.
There are some things we miss from Windows in Ubuntu.
Yep.
MS Word, MS Paint.
Yeah, there are like rip-off versions like LibreOffice, Libre. Uh,
uh,
yeah, that
okay.
is not.
Yeah.
Yeah.
So let's say this whole page is our system. So we make a workspace here. Sorry for the handwriting. Okay, and this will contain all the things that are required for our project. So we had devel, just write a D here. We had a source and we had a log. So I'll just make this log and I'll make the source a bit bigger. So this is our
Source
source.
is basically SRC. Don't confuse it with source devil cell.
Oh, yeah, yeah. Okay, just this contains your setup.bash, which you have to source every time. And now your SRC will contain your packages. Okay.
And by the way, if you don't have an SRC folder, your catkin build will not work. Catkin build or catkin make.
Yeah, you need to have an SRC. It will create all these by default, but you need to have an SRC.
And the exact name, small case SRC.
Yeah.
Without that, it won't work.
Okay. So now we need to make this. So by this time we know how to make this workspace, and we know how to make this devel, this log and src, and there is also a build folder. I'll just write it here. So we know how to make this using catkin init and catkin build. Now once we have src, now we'll make packages. So all these inner things are called packages, and how to make them we just saw here. So this is the command to do it. This is the name. You can see the format over here. Cat can create package. Then you type the package name, whichever you want. And after that, you write all the dependencies that you need. So we'll be using ROS and ROS CPP, and this will come to it later where we use the messages part, which is like right at the end of the PDF. I go over it. If we have time, we'll do. Otherwise, we'll do it in the next session. So you write all the dependencies here, or as Akshat said, what you can do is you can just make normal folders and then just do a catkin build on it, so it will automatically work. But since this is the official way of doing it, we are going over this. Otherwise, you can use the simpler way also.
Yeah, and by the way, more importantly, if you're copying someone's workspace, you can just git clone inside your SRC and that will work as a proper package after you do a catkin.
Yeah. Okay.
Yeah,
So
later.
yeah,
Yeah,
we
when you copy our packages.
yeah. So we will name our package beginner tutorials. So if we go in the Jamboard again, so this thing will be named as beginner tutorials, and this will be using ROS by ROS CPP and standard messages. Rip ink. Yeah. So now to create this, what we did was we executed this command. So by the format we go, this is the command to create a package. This is the name, and these three other dependencies that we'll be using: standard messages, ROSPA, and ROSCPP. Now all these follow-ups will show the status, like created a file package.xml, cmaclist.txt. You don't need to worry about this in early stages because these might not be very relevant to you. And oops, yeah, and then it'll show like successfully created files. And yep. So if you go and check in your catkin ws src, you'll find this package built. So what this is, this thing, this is named beginner tutorials. um yeah. So yep, this is what it is, and these are all the basic things that are always there in the package. So this will automatically be created if you do a create package. So yep, I think now it should be more clear. If you want us to repeat this again, please ask, because we don't want you to miss out on important stuff. Anyone?
Also, like it might feel as if lot of new commands and information have come to you in a single day. So you don't need to worry about it. You don't need to like remember all of them. Even sometimes we have to refer to certain commands because we tend to forget over time. So basically, you just need to know what each command does and like how to like deal with that command basically.
Yeah, and I'll send you this PDF, and I'll add all the things that we missed out while writing, but we covered it in the video, so you don't need to worry about it. You'll have this documentation, so you can always refer to this as well as you can. Okay, one more important thing. Since we started with ROS, there is a website called wiki.ros.org. So this contains all the documentation that is available for ROS. And if you go in tutorials, you'll find all these. I think the first 16 tutorials are relevant. Yep, here. These 16 tutorials are relevant. And like if you want to read in detail, you can read through these also. But the only disadvantage for in this is that there are a lot of complicated like text which you might not understand right now. Like there are like suggested modifications in the CMake lists and all, which I don't think anyone wants to like play with in the beginner stage. So that is the only disadvantage of this, but you can always like refer to this in correlation to what we are teaching, so you'll find pretty much the same thing whatever we are teaching here. So you can like just go through this if you are still not clear about anything. This is everything which we have taught till now, all the workspaces and all, everything you can find it here. Right, so I'll put this link in our chat if anyone wants. Okay, so shall I continue then, or like anyone has anything to ask? Or if it's too much, then I think we can take light for today. It is up to you guys. Like, let's have a poll. You can like post your opinions in the chat. If you think this is too much for today, we can just pause here. Or if you think we can like go a bit more deep into nodes, etc., then okay. So from nodes, the exciting part actually starts. You'll be actually having control over things. So yeah, up to you guys. Yeah, please type in chat whatever you feel. Can. Okay. Oh, can we pause? Fine. Can you tell us what is a service? Okay, I think like the appropriate time for telling what a service is after we do messages. So just remind me at that time. I'll let you know in detail what a service is. A bit heavy info. Yes, I agree. Since we have only 8 sessions, so we'll have to rush through things. But yeah, I think we can pause it for today. So those who feel it is very heavy and you want me to repeat over anything, so you can just ask me. I'll do that right now in the half an or in the 20 minutes that we have remaining. So you can type any topic you want in chat, and yep. Where can we learn these terms in detail? Wiki.ros. I've
And there
sent
are
the
plenty of YouTube videos, bro, like which will basically tell you whatever we are teaching, and
yeah.
maybe even
Yeah, the
in a,
only disadvantage of going through documentation or going through YouTube videos is they'll teach you a lot of things that you don't actually require for what we are doing. But like, yeah, learning is not bad, obviously. But if you have less time and all, it's better to stick to what we have. But yeah, you can always, if you have interest, then you can always go there. And
and obviously we don't expect you all to know all of those things by the end of like 8 sessions. Like basically get the gist of how things work so that you can work on it like on your own pace and like understand stuff. That's the goal basically.
right. Okay, so like since Ayush and Akshat explained you all the dual booting slash VM stuff, so you can just like start with your system, start making your system, and you also covered the install.sh, right, Ayush?
Yeah, yeah, they
We
like
did, we did.
Yeah,
yes.
so you can just like start running the script. If it is a fresh system, so there will be like I'm 100% sure there won't be any errors. But like if you run across any, you can just ping us on the group. We'll try to reply as soon as possible. And like all the script was tested on this system only, so yeah.
Also, HP laptop users can contact me. Dell laptop users can contact Akshat.
Yeah. Yeah, see, like I used this script yesterday itself. This was named trial.sh because it was a not trial, but I renamed it to install. So yeah. Uh, Anyway, so anyone has anything to add? Otherwise, like we'll just recap everything we learned today in 10 minutes and then we'll dismiss the session. Okay. So yeah, we learned what a workspace is. So let's like wait, I'll explain here itself. So yeah, this is a workspace which you create. So what a workspace is, it contains all the projects. Like let's say you're doing a particular project, so you can make a workspace in your home directory for, and you can like add stuff for your project here. So a workspace basically acts as a daddy folder if you get it right. It contains everything you need. So yeah. In also okay. So in the workspace, then you do a catkin init. Wait. Yep. So you make a catkin workspace and a folder called src inside it. Then you go in your workspace and do a catkin init. I'll just add that line here. I forgot to add it here. So when you do a catkin init, you will find the src and all stuff made. Then you have to do a catkin build. So you first do init, then you do a build. So you have all these small folders present here, devel, logs and build, and you also have a src folder. So once you are done with this, you can go into your src and you'll start creating packages where all your important stuff like libraries and your scripts will reside. How to create a package, we learned it here. Catkin create package, name, dependencies. Or what you can do is you can just make a folder and do a catkin build on it. I'll just show you that as well. So in src we need to make a folder. Just a sec. Yeah, so I'm inside src and you can see we have a beginner tutorials here. So I'll just make a directory called sample package. Okay, and so if you do ls, you can see I have a sample package here. I'll just go back one step and I'll do a catkin build here. So wait, I think it didn't work. ls. Yeah, so you have a sample package ready over here, so you can do this as well. Not a very big deal. So we don't need this right now, so I'll just delete it. Not an issue. But this is also a way where you can do. But I'll prefer if you're like starting using ROS and all, I'll prefer you use this method because it'll get you more used to what all dependencies and these things you need. And yeah, I think that is what we did today. Also, we talked about bash rc, and so bash rc is like a collection of all commands that you want to execute before your terminal starts so that you don't have to do it every time. So I'll add about bash rc also here. So yep, that is it. And I think we can end this session today. I'll provide you the PDF by night. This time it won't be delayed because there's nothing to add. And as soon as the recording is ready, I'll upload it on YouTube as well. So you can go through that later on. So yeah, now we are open to doubts. Those who have no doubts, you can all like leave. No, not a problem.
Yeah, by the way, Shubham, you said that this was getting heavy. So yeah, it is heavy. So the thing is that just stick around for a few days. It'll make complete sense why we are doing all of this. And when you see it in practice, it'll make more sense.
Yeah, like I remember when we first did this and we like ran our drone command first and like you could feel the inner happiness when you do this.
Yeah,
So
because there's like 10 hours of setup for that.
yep. But then you like start to realize how versatile this thing is. So yeah.
It's so like once you start using these commands frequently, these this will seem like peanuts to you. Like these commands, and they'll be like you can you'll get so
Yeah,
used
it'll
to
be
them.
second nature basically.
Yeah, it'll become second nature for you. Yeah, exactly.
And some people prefer Ubuntu over Windows. Am I right, Ayush?
Definitely, bro.
Right
Windows
then.
is
Okay,
later
guys,
on.
any questions and stuff?
Yeah, I'm also writing. I'm also waiting for practical projects too. Yeah, yeah, sure.
Yeah,
Could you
so
repeat
soon enough
that?
we'll have projects like make the drone go in a hexagon, make the drone go there, like automatically, not with a.
Yep. Okay, so about the bash RC thing, so for, like I'll have two terminals. In one, I'll just open bash RC dot bash RC. Okay, so bash RC is present in your home directory and its name is dot bash RC. If you type bash RC, it will say no file found. Okay, so this is your bash RC. Now, what you should do here is like we created a Catkin workspace, right? So do you want me to show it in the terminal, or you want me to go through the files part? In whichever way you will understand it better, I'll go through that. Okay, how about both? Yeah, so in your Catkin workspace, you have a folder called devel. This is your folder. So if you go in the devel folder and do an ls, you will find uh, you will find a file called setup.bash. So this, like as Akshat said, this file, like, you need to source this file in order to access whatever is there in the workspace. So in Ubuntu terminal, what you should do is you should source that file. So you should be doing this source and setup.bash, or like if you are on home, so you should be doing source and you type the entire path. So you like catkin ws, then sr sorry devel, and then the setup.bash. But the bash rc gives you a feature where you can do this before the terminal even starts. So like all this will be done here, and then this line will be shown to you. So what you can do is you can just pick this line, you can just copy, and you can paste it in the bash rc here, and you can save here. You can just control save it, control s it, and you can just close it. So whenever you open a new terminal here, so this thing, this command, oops, sorry, I should do control plus. Yeah. So this command will all like this command will already have ran before this line is outputted to you. So you don't need to source it again and again when you're using it. And this is in use like when you have multiple workspaces and stuff. So you don't need to like mess around sourcing things. You can just directly work on your problem statement. So yeah, I hope it is clear now. Okay.
Interesting. We are still recording, guys, by the
Oh yeah, not to just stop it.
way.